Hello everyone, my name is Viraj, and today we'll be looking at the third problem from the CP-31 sheet by TLE Eliminators under the 900 rated questions. Let's go. So I'll be moving on to my CP-31 sheet over here. I have ticked off my 900 rated parameter and I am going to solve the third problem, Vasilije in a Cacak. Alright, let's open this. Okay, so Aka and Milovan, two fellow competitive programmers, decided to give Vasilije a problem to test his skills. Vasilije is given three positive integers n, k and x, and he has to determine if he can choose k distinct integers between 1 to n such that their sum is equal to x. Now, since Vasilije is in the weirdest city in Serbia where Aka and Milovan live, the problem is very weird to him, so he needs your help with it. Alright. So let us try to generalize this problem. Very, very simple problem. They have taken simple variables for us to understand. They have three variables with them. One of the variables is n, then they have k, and then they have x. Now what are they saying is, if you have the variable n, that basically means you have integers from 1 to n. When we talk about x, you have a sum that we want to create, which is equal to x. You can say this is equal to x. And this sum which you want to create is from the integers 1 to n only. But the condition is from 1 to n, I want to pick up exactly, you can say exactly, k distinct integers. Distinct integers. This is the condition. Now what is the meaning of this? Let's take a small case. Let's say you're saying n is basically 5, k is let's say 3, and x is 4. Just an example. So what are we trying to picture is, if you have n5, that means you have integer 1, 2, 3, 4 and 5. And if you want to create x equals to 4 as a sum, you want to do it by taking exactly 3 distinct integers in them, distinct integers out of this. So maybe you pick up 2, 3 and 4. Maybe you pick up 1, 2 and 3. Maybe you pick up some other 3 distinct integers, but your case is you have to pick up 3 distinct integers, sum that up, and you have to see whether you can create a sum x equals to 4 or not. Now, if you can do it, what are they saying in the problem? Let's go back. If you can do it, print a yes. They're not saying you need to print those numbers. That's not the case. They're only saying if you think you can do it, print a yes. And if you think it's not possible to do it, print a no. That's all there in the problem. So let's see the sample cases and understand this much better. You have over here, let's say 5, 3 and 10. So this is a nice example. They have said, I'll take this over here only. Let's say you have 5, 3 and 10, which means n is 5, k is 3 and x is 10. So n is 5 means I have all the integers 1, 2, 3, 4 and 5 available with me. And I want to take up exactly 3 distinct integers, and I want to create a sum equal to 10. So what I can do very simply over here, I can see this, I can take 2, 3 and 5. What happens? I have taken 3 distinct integers, 2, 3 and 5. Of course, you can count that by fingers also, 1, 2, 3, 3 distinct integers. And if you sum this up, you get 10, because 2 plus 3 plus 5 actually gives you 10. So you are getting the sum as 10. You are satisfying the condition, and you're also following this condition that you have 3 distinct integers or k distinct integers. So can I say that the answer is yes? Now I'm not asked about this 2, 3 and 5. Maybe there was some other solution which could have achieved this. That's not what our concern is right now. Our concern is, were we able to do it? If we were, we printed a yes, and in this case the answer is yes. And if you would argue that we will never be able to do it, we'll print a no. So that's why if you pause the video and look up the other cases, you will understand briefly when they are saying briefly the answer to be no, or when they are saying the answer to be yes. You will get this part when you take up your copy and pen. Alright. So this is the whole problem. Very, very simple problem to understand. Now, before we actually proceed in the problem, let's think about the time complexity that is arguably important in this problem. Alright. Something that is very crucial to formulate an idea and remove all the redundant pieces I could have actually solved. Alright. So over here, by simple terms, I know 1 second allows me 10 power 8 elementary operations. Now in this problem, I have been allowed that time limit per test is 1 second. So if I talk about one test, I'm basically talking about 10 power 8 operations. Alright. So if I look over here at n, k and x, all are very, very huge. This is like 10 power 5 order over here, and then this is like 10 power 10 order over here. So I'll just assume some simple things. All right, we are not exactly finding the time complexity, or we are guessing exact piece of time complexity structure. We are estimating some orders, right? So let's just say that n is like the most best variable to bet our time complexity on. Let's just say that we are highly dependent on the orders of n in our time complexity. Then I know over here that since I have been allowed in one test 10 power 8 number of operations, and if I look over here at t, which is the number of test cases inside every test, I have been given a higher order of 10 power 4. So I'll take this test case and n into count. I have, first of all, I know that number of operations I'll be allowed per test case would simply be 10 power 8 operations. That was for every test inside which I have 10 power 4 test cases. So this gives me 10 power 4 number of operations. So this is for every test case. Now inside every test case, I have n. And since I'm taking an estimate that my time complexity would be on the orders of n with terms to dependency, I know this is in 10 power 5 order, or to be specific, this is 2 into 10 power 5. So that tells me something very simple. If I'm talking about a 10 power 4 number of operations in every test case, that's a limit. I know I cannot create a solution that runs in even in O of n order, or basically in a 10 power 5 order, because O of n would be a 10 power 5 order. I cannot do this because O of n gives me something that's above 10 power 4. I want something below this. So just an estimate below this gives somewhere around log powers or constant powers. So if you're able to create a solution that looks like log base 2 of n, then that is pretty much good to go. Or even if you're able to create a solution that's constant, then also that's great. So solutions like this work, which is below 10 power 4, but solutions like this don't start making sense. And of course, if this is not working, anything above that will not work. O of n square will not work, O of n cube will not work. So this tells me this problem requires a log factor of calculation or a constant calculation. And this is where I have a decent guess of what the problem will require. This is an expected time complexity discussion. And why is this helping me guess some intuition in the problem? Because mostly problems which have log powers expected or constant powers expected look for a solution that is very formula based, or something like a mathematical formula, a mathematical proof based, you can say, where you're able to come up with some correct intuition and you're able to finally code it out in a complexity where you just directly put up values and you get the result. So that is what happens in constant time period, and that can only happen when you have some maths deduced from the problem. So this problem is hinting me now that since this time complexity is expected, I want to do something like that. Alright, so this is the guess intuition in my problem. Let's actually discuss the problem now. So since we are pretty much up to the point that, okay, intuition gives me something like mathematics, that means I want results very fast. So I'll start asking questions like that only. First of all, I'll start asking myself is, when I take up k distinct integers, that's very important. I'm taking k distinct integers. I am obviously creating some sum. What is that limit of sum? That is, what is the minimum sum you can achieve and what is the maximum sum you can achieve? That's a very important question. So let's say you have the numbers like 1, 2, 3, 4, 5, dot, 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 dot. Let's say from the back like n minus 2, n minus 1, n. Now you have to pick up k distinct integers, right? If let's say I talk about k distinct integers to pick up, if I ask you what's the minimum sum you can create? Minimum sum you can create. That is a sum below which you cannot go. Greedily think about this. If you want to create the lowest possible sum from k distinct integers, choosing from these 1 to n numbers, will you prefer numbers which are very high, or will you prefer numbers which are very low? If you want to choose k distinct integers and I tell you, okay, choose this integer, then to choose this integer, will you prefer to choose a higher integer? No, right? Because you want to create sum to be very low or sum to be as low as possible. That means it would make sense if, let's say, just say if k is equal to 4, then I will want to pick up the first 4 integers, that is 1, 2, 3 and 4. Will I want to pick up numbers that are 1, 2, 3, 5? No, I will pick up 1, 2, 3 and then the next best would be 4. Not 5, 4. That means I would want to pick up the first 4 numbers from 1 to n in a sorted manner, basically. That's true. That would give me a minimum sum. This makes sense. Now, what about the highest sum? Let's say I'm talking about the max sum. Maximum sum. How do I get that? Of course, since I want my sum to be very large and I want k distinct integers, by common sense, it makes sense that I would want to take up the largest k numbers possible. So I have 4 numbers from the back, n, n minus 1, n minus 2, and this number would be n minus 3. I would want them to get added up and this would give me the maximum sum possible. All of this should pretty much make sense. You can pause the video, give it 2 minutes and you will understand the whole part. Now, why am I calculating this? Because I have a very strong argument over here. The argument is, you wish to make X as a sum. This X sum should be greater than equal to minimum sum and less than equal to, you can call this like X is greater than equal to minimum sum and X is less than equal to max sum. I think this argument should be very simple to understand. We have a minimum sum that we can achieve. We have a maximum sum that we can achieve. Of course, X has to be between that. I cannot create a sum that's above maximum sum, right? If the best sum I can create is by taking these four numbers, last four numbers, can you create a sum after that? No. Similarly, the lowest sum you can create is the first four numbers summation. Then you cannot create anything below that. So X has to be within this range. This should make sense. Now the argument is, since this X sum should be within this range, it should be greater than equal to min sum and less than equal to max sum. If it is actually greater than equal to min sum and less than equal to max sum, you can always create X. Hence the answer is yes. Else, if X is not in this range, the answer is no. I'll repeat this again. If X is within the range of min sum to max sum, you can always create X by taking up k distinct integers. And if your X is not within this range, then you can never create X. Now, when I try to talk about this no part makes pretty much sense because we just said the sentence, right? X has to be within this limit. Now, we are not sure whether we can create it or not. I'm arguing that we can create it. We'll try to see why. But then the other counterparts as to when we cannot create it does make sense. Of course, when it's not in the limits only, you cannot create X. So the no part should be pretty much clear. It's not in the min sum to max sum limit, cannot create X. But I'm arguing that you can always create X with exactly k distinct integers when it's between min and sum and max sum. Let's try to look at a very, you can say, simple example and get this visualization running. So let's say your integers are 1, 2, 3, 4, 5, 6, 7, 8. That's all. Let's say only this much, or maybe I'll take something like 9 more. Okay, and so on, and then it extends to n. Now, let's say the minimum sum you can create, of course, if for k equals to 4 is the first 4 value summation. So first 4 values, 1 plus 2 plus 3 plus 4 gives you 10. So I know min sum is 10. Now let's say n was maybe not over here. I'll just remove this n. Let's say n was actually 9. So I took up first 9 numbers. So if you talk about the max sum, you can get the last 4 numbers sum. So you basically get 8 plus 9 plus 7 plus 6. So if you quickly add this up, you will get 30, right? You will get 30. Now the argument is you can actually create any sum between 10 to 30. Let's take an example. Let's just keep on iterating one value above 10. So let's just say that somebody comes up to you and says, okay, I want a sum that's not 10, it's actually 11. So let's just picturize this diagram. I have drawn a segment over here which says 1 to 4 is what I took. It gave me a sum 10. Now somebody says, don't create a sum 10, rather create a sum 11. What can I do? Just picture this part. Maybe I just remove, like, since I want one added value to 10, that is what would give me 11, I can just not utilize this 4. Instead, I can utilize this 5. So I get 1 plus 2 plus 3. No, 1 plus 2 plus 3 plus 5. So I added one more to my initial sum and now I have 11. 1 plus 2 plus 3 is 6. 6 plus 5 is 11. Yes. Let's say somebody argued, okay, I wanted 12. Then I could have taken 6. I would have gotten a 12. If let's say I wanted a sum at 13. 1 plus 2 plus 3, that's constant. Maybe 7. Then I get 13. Up till 14 term, you want plus 8. 15, you want plus 9. So 1 plus 2 plus 3 plus 9 would give you 15. So did we not see that we were able to create 11, 12, 13, 14 and 15? Now I leave this up to you. You can actually see that you will be able to create 16 also, 17 also, 18 also, and so on till 30 also. If you do, just pick up your pen and paper, just jot down these numbers, and I can guarantee you will find these numbers with a very simple part. And that's actually the proof. It's sort of a visualized proof. You can see yourself that that's happening. And the very simple reason is just how we saw this pattern. If you are able to create a sum S, you can always create a sum S plus 1 by just shifting a bit and maybe increasing your overall number, any one number in that, to be of that current value, let's say v to v plus 1. You will create a sum of s plus 1. Then from that, you can again argue that I will create s plus 2. From that, you can just counter at and argue I'll create s plus 3, s plus 4, and so on, so on, so on, till you of course reach the maximum sum. So this pattern following helps you actually yield up all the sums between 10 to 30, on this case minimum to maximum sum. And that's actually the argument. Hence why this argument is true. If you want to create x as a sum and x lies between min sum and max sum, then your answer is yes. And if it doesn't lie within that range, your answer is always no. Alright, so I hope the whole problem is clear. Now it becomes a very implementative detail. So as to how do you find this min sum and max sum? Min sum is pretty much clear. If you want to find the minimum sum, basically that's saying I want to find the sum of the first k values, right? First k values. So you can treat that as the sum of first k natural numbers, right? And to do that, basically for sum of first n natural numbers is n into n plus 1 by 2. In this, you can just replace k. So you basically get min sum. If I talk about over here, I'll take this to the new page. What you can do over here is you can say I would get min sum as k into k plus 1 by 2. So that's actually the first k natural numbers sum. And if you want max sum is basically, it's kind of tricky. You can understand this by visualization again. You want the sum of the last n numbers, right? Sum of the last n numbers, which is this. Now to calculate this, of course, you can have some integrate formula, or we can use a very simple theory called, it's kind of a prefix sum based theory. What we can do over here is, if you calculate the sum from or up to this whole limit, which is basically the sum of all the n numbers that is given, and you calculate the sum from this to this position, that is still 5. Let's say this sum is s1 and let's say this sum is s2. So s1 minus s2 actually gives your answer. This is a very simple technique. Now to calculate s2, s1 is pretty much clear because s1 means I'm calculating the sum of all n numbers. So that's basically n into n plus 1 by 2, where n is that variable that is given to you in the problem. But if you want to calculate s2, it's kind of tricky. You can simply understand that since you want this up till this position or this number 5 is actually n minus k, because n is you can say 9. So 9 minus k is 9 minus 4 means that gives you 5. So this number actually is n minus k. So considering your formula was n into n plus 1 by 2, you replace n into n plus 1 by 2 with n being that variable to n minus k. So you basically get n minus k into n minus k plus 1 by 2. This is simple mathematics. If you're not able to understand this, you can pause the video. Just give it 2 minutes thought and you will get this picture. It's basically the formula of n, the first n natural numbers, where I'm utilizing that with keeping variables wherever I want. So first I kept it as, over here I have kept for s1, I've kept that n directly. For calculating s2, I've kept that variable as n minus k. So wherever it's n written, you can replace that with n minus k. So you get n minus k into n minus k plus 1 by 2. And for the first k natural numbers, you just kept that n variable with replaced with k. So you get k into k plus 1 by 2. So you can calculate s1 and s2, and you can just subtract s2 out of s1. So you get n into n plus 1 by 2 minus n minus k into n minus k plus 1 by 2. So this is min sum, this is max sum. You will be given an x variable. Just check whether this belongs to this range or not. And if this belongs to this range inclusive, you say your answer is yes, else you say your answer is no. Very, very easy problem. Alright, now let's look at the code part. It's going to be very simple mathematics we want to do. I have taken long of every type. So I first take the input of the test cases, then I take the input of n, k and x. So up till here all I take is inputs. Then I have done direct calculation. I calculate minimum sum, that is k into k plus 1 by 2, and maximum sum n into n plus 1 by 2 minus n minus k into n minus k plus 1 by 2. So this gives me sum of first k numbers, and this gives me sum of last k numbers. All right, or you can say like sum of k lowest numbers. This is even a better thing to write. And you can say this is sum of k largest numbers. All right, all unique, of course, from 1 to n as you're following the condition. Hope that should not be a problem to visualize. And then all you want to check is does x belong in this range or not. So x is greater than or equal to min sum and it's less than or equal to max sum. Print yes, else print no. Well, it's a very, very simple problem. So what do we think is the time complexity? Of course, I am achieving a time complexity that's constant, all right? So I'm getting something like a constant time complexity even for this calculation of min and max sum. Then all I have is if checks. So it's not a very big deal, right? Very easy to see time complexity is constant. And this is very good for me because I wanted a time complexity that was below 10 power 4. I achieved a time complexity that's constant. It also validated my idea that problem like this, I was looking something that was in log powers or constant powers, or typically something that's a mathematical formula. And we can see over here, we did deduce that with very clever mathematics. We were able to get the answer much quicker. Alright, so this is the whole ideology. Now, what about space? Space is also constant since you're not using any extra data structure besides some variables to store the answer. So space is pretty much constant. So you have solved the problem within the boundaries, of course, and since the logic is right, this is going to fetch you an accepted solution. Clever problem, right? Requires some mathematics, which would be very easy if you understand the expected time complexity discussion. That's why its importance. And then this whole idea of proving or counter proving is important. Definitely requires some pen and paper in the first go, so you can test out your own test cases and you will see why this is correct. Alright, so I hope you like the video. Thank you for watching.